Hello friends, welcome back to my YouTube channel Rishabh Jain Pharma. If you want to reduce the human error in any industry, then it should be replaced with the automation. How much automation is there? How much involvement of the human it reduce, the error will be reduced. But if you go in the QC laboratory in the pharmaceutical industries, there is some area where still there is no automation. For this, the solution preparation also in one area where if you want to analyze any product in any instrument, like it may be HPLC, it may be EV, it may be any instrument, it may be Malvern particle sizer, everywhere first you to prepare the solution. Then this solution has to be injected in the HPLC, has to be analyzed in the different instrument. But this solution preparation is very important. If you evaluate your all the error in the laboratory, that include solution error, transcription error and other error. If you identify the number of error of solution preparation is very high. How to reduce this? Because currently if you see there are so many warning letters related to the human error. So how to reduce the solution preparation error? In today's video we'll discuss in this topic. Let's begin. So what is the main error during the solution preparation? Sonication. Sonication error is the error where if you identify in the solution preparation, mixing error is there, dilution error is there, and looks like same volumetric FLASK pipette error. It is part of the solution preparation error. Wrong FLASK selection for HPLC while filling for final analysis in any analytical technique. So what is your final dilution? And this dilution has to be used for the instrument analysis. That will be chance people are used wrong FLASK. This all are the error you will be see in the solution preparation, and we have to be discuss how to handle this all the errors. So let's start with the sonication error. Sonicator is not working properly means when you switch on, the vibration is coming and noise is also coming. So it looks like sonicator is working properly, but however what happened? Some corner having the less sonication. The frequency of the sonication in the some corner of the sonicator is not properly. So first you to identify your sonicator is working properly or not working properly. There is so many instruments available in the market. In this way you can check in the sonicator in the all the corner everywhere the sonication frequency is same. So for that there is the one instrument that it may be available PCI in other available market. So you can use this rod, you can put this rod in the different area of the sonicator and you can check the frequency. If all the area of the sonication frequency is same, then you can use this sonicator. If it is not same in the all the area, then it should not be used and go for the maintenance. So first you to check your sonicator should be work properly. Then another is temperature of sonicator. Some sonicator if you see is attached with the cooling system, so that can be maintain the temperature. But some sonicator is not attached with the cooling system, so they cannot maintain the temperature. If you start the sonicator after some time the temperature of the water is increases, that can be also impact your sample. In such sonicator what can be possibility, what you can do, you can put one tap water has to be continue supply the water in the sonicator and drain also open, and the tap, the volume of the water has to be fixed such a way the water level has to be maintained. So the flow of the water in such a way, water level has to be maintained, water has to become inside to the sonicator and it will be drained to the sonicator. So in this way continue water changes, continue water supply is coming, going, coming out, so the temperature of the water can be maintained. In this way you can maintain the temperature If you want to avoid, you can use the sonicator which having the cooling system. That also good idea. Then time of sonication. So how to identify time of sonication in the worksheet, in the test data sheet, when you are keeping your volumetric flask and solution in the sonicator, you can start time and you can write end time. If it is mentioned 10 minutes, so what is your start time of the sonication of your flask and what is the end time? You cannot write like 10 minutes because in the STP it is mentioned the sonication has to be done for 10 minutes, and the worksheet and test data is always copy paste to the STP. So people writing only 10 minutes. No, this is not correct. You can write when you have started the sonication, when you end the sonication. So start time and end time has to become in the worksheet and test data sheet. This is first. Second, sometimes what happen, you have to be you are analyzing so many samples like 3 BUs, that will be 30 volumetric flasks, and standard if you put say around 34-35 volumetric flasks, sometimes 40 volumetric flasks. All the volumetric flasks cannot be put at a time in the sonicator due to the space constraint. So when you are writing in the test data sheet, if you have completed 10 volumetric flask sonication at a time, you can write the 10 volumetric flask number this to this done from this time to this time. Next 10 has to be done from this time to this time. In this way, you can very clearly identify how many flask is completed in what time, and the sonication is done time as per specified in the STP. So this is way you can reduce the error for the sonication. Now another sonication error is miss to sonicate. If you have so many flasks that has to be sonicate, here I have mentioned only 5 flasks, but sometimes if you are doing 3 BUs, so there will be 30 flasks. 3 content uniformity, that will be 30 flasks, sometimes 120 flasks, sometimes 60 flasks, that based on the how much analysis you are doing. What happens, there are so many flasks is there, sometimes we miss the flask because so many flasks has to be done for the sonication. How to identify which flask is sonication is done, which flask is missed to sonication, that can be one error. So when you completed the sonication, you can put S. If you put S, it means this sonication is done. If anywhere S is not mentioned, then you can identify this flask sonication is not done. In this way, you can eliminate this error for the sonication. So when you complete the sonication and you are taking the flask out the sonication, then you can write S. It means this all the flask sonication is done. So during the evolution, during the monitoring, you can identify, oh, in this flask S is not mentioned, means it is missed for the sonication. This way you can identify which flask sonication is done, which flask sonication is not done. Mixing error. So what happens, sometimes this analyst has to be not mixed properly. So if it is not mixed properly, there will be chances of the incident OOT. So how to mix it? For the mixing, you have to be use the stopper. The stopper the volumetric flask, turn the flask upside down, holding the stopper to prevent any spillages. So that will be correct procedure. And when you are holding up and down, you have to be shake properly. When you are shaking the properly, then your flask will be mixed properly. In this way, you can mix your solution properly. If you are not mix the solution properly, there can be chances of error. This is the correct way. You can mix the you can mix proper your solution, and that procedure has to be done 7 to 10 times. So 7 and 10 times you can up down, then shake it, then up down, shake it. In this way, the mixing has to be done properly. Now sometimes mixing is error means you have to be mixed solution not mixed properly, yeah, mixed to mixed. So again there will be flask I have mentioned here. When you mix properly the flask, you can mark as a M. It means it is mixed. If any flask is not mixed, then you can identify, yes, this flask is not mixed. In this way, you can identify which are the flasks mixed properly, which are not mixed properly. Looks like same flask and pipette error. So if you see flask like 20 ml and 25 ml, 200 and 250 ml, it looks like same. If you see in the pipette, which is very near 2 and 3 ml pipette, 4 and 5 ml pipette, like that the pipette also looks like same. So sometimes what happen, analyst take the wrong flask. Instead of 20 ml, he has to take 25 ml like that. So for that, there is a very old system. You have to be mark one flask. Here I mark 25 ml as a red color, so it can be identified. This is 25 ml, and there is no color. It means it's 20 ml. Like I have marked here for 250 and 200 ml. So here 200 ml mark is like that. So you can identify very clearly. But if you see, this is very old where the marking system is there nowadays. In the market also, if you see, the different shape of flask is available for 20, 25 ml and 200 and 250 ml. So that can be procured from the market. It is very easily identified. This flask is not looks like same. So in this way also you can reduce your error. For the pipette, you cannot put a pipette like in the same place 2 ml, 3 ml, 4 ml, 5 ml. What you can do? You put 2 ml pipette with the 5 ml pipette or 10 ml pipette. So it can be very clearly visible. Yeah, this is 2 ml pipette, this is 3 ml pipette. So you cannot mix all the 2 ml, 3 ml flask. You have to be take different pipette in a one place. 2 ml has to be put with the 10 ml and 3 ml has to be put with the 15 ml like that. So that can be identified. This is one error which is seen during the solution preparation. So let's discuss the dilution error. Some error has happened due to during further dilution analysis will transfer 2 times solution in volumetric flask if quantity is less. I will give one example here. I have one stock solution. From this stock solution, I have to be transfer 1 ml solution in the another volumetric flask for the further dilution. So I have transferred 1 ml with the further dilution with the one flask, and in this between some friend has come to me, some phone call has come, I missed and I forget it. I have already transferred 1 ml here. Now what I did, I again transferred 1 ml because this quantity is very less. So it's not identified very clearly in the flask. If your flask is 100 ml, if flask is 200 ml, then it's very difficult. So what happened? The analysis missed, and what he did, 1 ml one time, again 1 ml one time, so he has transferred 2 ml. Sometime what happened, he has missed to be transfer also. It may be chance he has missed to transfer, yes, sometime by mistake transfer 2 times. How to avoid this? For example, here there is the one flask, here he has transferred 1 ml. Now when he transferred 1 ml, he has to be change his place. Now when he change the place, it means already transferred here. Now this is the second one. He has transferred 1 ml solution here. Now he has changed the place. This is third also, and this is fourth. In this way, all the flask is shifted in one place to another place. It shows all the flask transferred 1 ml, and it can be avoided. In this way, you can avoid the dilution error to transfer 1 time, 2 time, yeah, miss to be transfer the solution for the further dilution. So another example for the dilution error which is happening in the lab. What happens? Sometimes standard concentration is same. However, for different strength, formulation, sample, dilution are different. So your boss has given you two different strength for the same product. Now you have to do the analysis. Here the standard concentration is same, but your sample dilution is different. Let's have an example. Here this is stock. In this stock in the 100 ml. Now you have to be take 5 ml this solution and put your final dilution. This is dilution of the one strength. When you prepare this solution, you have to be transfer this final dilution in the HPLC vial, and this HPLC vial has to be transferred in the HPLC, and this all the things you have to be kept in one tray. Now till time when you completed your one strength, don't touch another strength sample, don't start the dilution of another strength. Now this has to be kept in one different tray, different area. Now what you will do, second strength, you can take the second strength, make the stock, dilute this 10 ml to again in 100 ml flask, and now this is your second strength. Again this second strength you can put in the HPLC vials and transfer in the HPLC. if this is HPLC analysis. If it is UV analysis, the same procedure has to be followed. So when you prepare the one strength solutions, you can transfer this final flask to the near to UV. You can transfer your final flask near to the UV. And what you can do, after the transfer this final flask in the UV, near to UV, then you can start your second strength. And when the second strength also prepared, first you complete UV analysis for the first strength. Then after the completion, you can take this second strength flask near to UV and do the analysis. In this way, you can avoid the dilution error if you have different strength with the different sample dilution with the same standard concentration. Now, wrong flask selection for HPLC while filling. Now here, if you see, there are 250 ml, there is one stock. Then in between you have first dilution is again 250 ml and the final dilution is again 250 ml. During the taken the sample in the vials, what mistake has to be done by the analyst? He can use, it may be first dilution, he can use in the stock solution, and he transferred wrong sample, wrong solution in the HPLC vial due to the wrong result. How to avoid it? So for the stock you can put yellow mark, then first dilution you can put red, and for final dilution you can put green. In this way, after all the solution preparation, you can identify all the green has to be transferred in the HPLC vial. So you can use different type of marker. In the market, if you see, red marker is there, green marker is there, yellow marker. So you can procure this marker. For the stock you can use yellow, for the first dilution you can use red, and the final dilution always use as a green. So when you are completed all, like your 8 batch, 6 batch, now you complete all the dilutions, then when you are transferring the HPLC vial, yeah, for the final analysis of any technique, you understand, oh, this is the green, now this is our final dilution flask. In this way you can avoid wrong flask selection for HPLC vial filling. Yeah, any other instrument analysis, not in HPLC, it may be UV also, it may be other analysis also, you can avoid this error. Friends, I believe I have explained here how to avoid the dilution error. So if you really like this video, please share this video to your friends. If you not subscribe my channel, please subscribe the channel, and please give the comment for this video. If you want to be learn any other topic, please mention in the comment. I will make this video for that topic also. So thanks for watching.